All right, so let's do another example of standard stereographic projection. And if you haven't watched this first example problem, I'd recommend watching that before you get to this. But if you're comfortable with the first example, then you can start the second one. And the previous one was a lot more detailed. Here I have listed out the steps that we did one by one in the previous example, and in this example we're just going to follow the steps and get to all the results, right? So let's look at the question real quick. What we are given is a standard that we have to draw a standard stereographic projection for 0 1 0, and then also another pole that is provided to us is 1 0 0. So this is the standard stereographic projection, and then the other pole that is given to us is the 1 0 0 on the north point. Now, let's just quickly review the steps that I've written out here, which we followed in the previous example problem. So the first thing is that we'll take this pole 0 1 0, put that in the center. Second, the other pole that is provided to us, which is 1 0 0, we'll take that pole and then put in the respective position. Here it'll be the north position. After that, we'll figure out the axis orientation through these 2 points and how that correlates to the stereographic projection that we are working with, or the wolf net. And then once we have figured out the axis orientation, we will be easily able to mark all the north, south, east, west poles or points. And then once we have finished that, we'll mark all the twofold poles using the vector sum rule. Then we'll also find all the poles in the outermost great circle, and then we'll also find all the opposite twofold poles, and then we'll join them, and then the intersection of those with the internal twofold great circle, that will be the threefold poles, right? So maybe it's a bit too much. I would recommend maybe writing this down in your note sheet or cheat sheet for the exam, just so you remember and you do not miss any of the poles. And this can serve as a good set of instructions to follow to quickly finish up the question regarding any pole finding. All right. So, and just to reiterate, for any fourfold family, so for example, we have the 100 family, we're going to be using a square box. Remember to not mess this up because this is very important, and that dictates the symmetry of that given pole. And then after that, let's just use the blue to represent any twofold, which would be given by the ellipse. And then lastly we can use the pink, and then the threefold would be given by a triangle. Alright, so these are the different shapes that we'll use to represent the respective family of poles. Alright, so let's begin. This is our wolf net, and as the first step states that place the given pole at the center. So this is the pole that is given to us, for which you have to draw the stereographic projection. So for whichever you have to draw the stereographic projection, that always goes in the center. So because here it is given that it is 0 1 0, once that goes in the center 0 1 0, that becomes our center square. And then the other point that is given is the north point, which is the 1 0 0 pole. So this is the north pole, and it is given to us that this is 1 0 0. So now we can try to figure out, so that is the step 1 and 2. Now we can figure out the axis orientation, which is the step 3. So let's draw these. So as you might remember, the pole in the center for which you're drawing the projection, this is the direction that comes outwards. So if we draw 3 different orthogonal axes, the one that comes out is this one over here, and here this is 0 1 0, which if you compare with xyz, you'll see that is the y-axis. And then the one that goes up 1 0 0, which is the north, that would be the x-axis. And then if you do an x cross y, which is the right hand thumb rule, just put your palm on the x-axis and then rotate along the y-axis, then you'll realize that this should be the z-axis. So in our system, this should be the east. So if we take the north, If we mark all the other, this would be the south, this would be the east, and then this would be the west. So after this, now we know that the east should be the z-axis, and for the z-axis it is simply 0, 0, 1. Alright, so let's mark that and then fill up all the rest of the poles. So with that, the east that we have is the z-axis, or 0, 0, 1. And then if you remember, the remaining ones, the south and the west, would just be the opposite. So this would just become 0, 0, 1 bar, and then this would just become the north was 1, 0, 0. So this will just become the opposite of that, or the negative of that, which is right. And then here it will have another square, and then same on the west. And do not forget to mark these squares and the appropriate and the correct corresponding notation. So these are all the two-fold planes. So we are done with the two-fold planes. Now we marked all the north, south, east, west, and then the step number 5 is to mark the two-fold 1, 1, 0 family of poles using the vector sum. So if you remember from last time, all the two-fold axes can be found as sort of the intersection point and the vector summation of these. So this is 90 degrees, this over here is 90 degrees, this is 90 degrees, and so is this. So we can do the vector sum for all these points and then find the 45-degree point and mark them. So let's quickly go through those, and then we can just mark them. So I'm going to zoom in a little bit and we can do it step by step. So let's start from here. So we'll count 10, 20, 30, 40, 42, 44, and then right over here we'll draw an ellipse, and this is 0, 1, 0, 0, 0, 1. The vector sum will just be 0, 1, 1, and this is our 0, 1, 1 pole. Same on this side, we'll do 10, 20, 30, 40, 42, 44, and then 45. Now remember, each of these big ones is 10 degrees and each of the tiny ones is 2 degrees. So now this ellipse will be the sum of the north and the center, and this is just the vector sum. So this just becomes 1, 1, 0. Alright, and then same on the left side where we have the west. So we'll do 10, 20, 30, 40, 42, 44, and 45. And this just becomes 0, 1, bar 1 as our pole, and on this side as well we'll do 10, 20, 30, 40, 42, 44, 45. Alright, so this becomes the sum of the south and the center, and again we're doing the vector sum, so that'll just be bar 1, 1, 0. Right, make sure you were able to follow along all these 4 internal two-fold symmetries, because that was the step number 5. Now maybe even now go ahead and try out the step number 6. You could pause the video and see if you can recall from the previous example problem and find out all the two-fold poles on the outermost great circle. And what that means is this outermost great circle. And yeah, go ahead, pause it maybe and try it out for yourself, and you should have 1, 2, 3, and 4. Yeah. Right, so let's do that real quick. So we'll step from the east and just keep filling it up counterclockwise. So we'll start with the 45 degrees. So 10, 20, 30, 40, 42, 44, and then 45. And this sum, I'm gonna erase this, and then I'll write that over here. Alright, and then this sum over here will just be sum of the east and the north, which just becomes 1, 0, 1. Now let's just do north and the west. So 10, 20, 30, 40, 42, 44, 45. Sum of the north and the west just becomes 1, 0, bar 1. Now west and the south, 10, 20, 30, 40, 42, 44, and this just becomes 1, bar 1, 0, bar 1. From the south and the east, we do 10, 20, 30, 40, 40, oh sorry, 10, 20, 30, 40, 42, 44. And you'll notice that they are also in the same great circle. Yes. And then therefore this just becomes the sum of the east and the south, which is bar 1 0 1. Alright, so now we have finished all the two-fold poles, both on the inside and the outside. And again, just to reiterate, this was the step number 6. Now the step number 7 says to join all the opposite two-fold poles from the outermost great circle, which are the outermost, and then the two-fold are the ones in the blue here, or the ellipse. So let's just go ahead and try to join them. And again, I would recommend just using a ruler to join these outside 2 points along with the center, because it should pass through the center. And this would be one of the lines, and then the other line would be something like this. Perfect. So once you have these two lines, now the next step that we talked about, again, just look at I would highly recommend noting down these steps, because you can just follow them along and you'll be able to fill up the entire projection. So we joined all the opposite two-fold planes. Step number 8 is mark the intersection of the above line with the internal two-fold great circle. What that means is that we have these great circles, or these poles, and we can draw the corresponding great circle for those. The easiest is to pick these two ones, because they lie on this diameter and they have their great circle right here. You could also pick these two, but then you'd have to rotate the entire projection to get an accurate great circle for them. But if we try to approximately draw a great circle for this, so that great circle would go something like this, and similarly on the other side. All right, so now let's just do the other side as well, and then we can move to the next step. So again, this is the step number 8, is just to draw out the great circle for these. All right, now you have these great circle which passes through both these poles. And here now the last step is mark those intersections as the respective three-fold poles using the vector sum. So what intersections are we talking about? We're talking about, I'll mark it real quick. We're talking about this intersection, this intersection, this intersection, and this intersection. So these are the 4 intersections that will serve as our three-fold poles. So now let's just go ahead and mark those. So let's start with this one. So once you mark the triangle, again remember this three-fold will have a triangle associated. Now how do we find the pole? The vector sum. So it's a same thing that we've been doing, is summing up the two vectors where this is bisecting. If this is 0 1 0, this is 1 0 1, this vector would just become 1 1 1. All right, and now same thing on this side. This intersection point will have a triangle, and will be the sum of 1 0 bar 1 with 0 1 0, and then sorry about that, and then this just becomes 1 1 bar 1. All right, and then the other two, which are on the lower side of this projection, a triangle here, we are vector summing this center point and the outside. So this just becomes bar 1 1 bar 1. And then the last one over here, which will just be the sum of this point on the outside and the center point. So that just becomes bar 1 1 1. All right, and this entire thing is the stereographic projection of 0 1 0, or the standard stereographic projection of 0 1 0. And again, we are only working with cubic crystals, so I have not been mentioning that, but that's why we use the orthogonal XYZ axes. So yeah, we drew a 0 1 0 standard stereographic projection where the 1 0 0 pole was on the north axis. We followed these steps one by one to generate this result. And then here's a more sort of a nicer graphic in case you want to take a screenshot and compare your results. Some of these things, as you can see, like are shifted a little bit, but you have the idea from the previous image of how to actually get the absolutely accurate information or accurate location. So yeah, go ahead, maybe try this out again. Note these steps down in your cheat sheet so you can follow it along. And then I'll do one more example problem after this, and then we can get into how to find angles, how to find traces, how to find zone axes, and how to mark other poles on the projection. All right, thank you.